Envision awakening one day and it isn't level to find that the world is not a turning circle, but rather something altogether unique, something that challenges not only your creative mind, but also hundreds of years of logical grasping. That is what the James Webb Space Telescope has done for our understanding of the universe. Get ready to abandon all that you thought you had some awareness of the universe as we dive into the noteworthy revelations that are making researchers question their most major hypotheses. Your idea of the universe is going to be irreversibly changed. Are you prepared? In the long records of human history, there have been a modest handful of amazing discoveries that have literally reimagined how we might interpret the universe. Copernicus moved the Earth from the center of the universe. Einstein supplanted Newton's general law of attractive energy with his theory of general relativity. Furthermore, now, drum roll, please, the James Webb Space Telescope is here, taking care of business. It's poised to be another Copernican moment, another Einsteinian discovery. Before we jump into the stunning discoveries, let's take a moment to appreciate this wonder of engineering and innovation. The James Webb Space Telescope, as it's lovingly called, didn't just work out by accident. It's the result of years of intense research, mind-twisting mathematics, and an international cooperation between NASA, the European Space Agency, and the Canadian Space Agency. The telescope is a complex ballet of mirrors and sensors that work together in the cold void of space to bring us the most detailed pictures of the universe that our eyes have ever seen. Now, let's explore what the universe looked like before we began revising its history. The universe's Big Bang and inflationary epoch are being completely reconsidered. So what's the primary sensation this galactic dynamo has unleashed? Because of the James Webb Space Telescope, the concept of a universe born from the Big Bang has acquired a mind-bending twist. The JWST has uncovered groundbreaking evidence supporting the inflationary model, a theory suggesting that before the Big Bang, the universe underwent an almost impossible explosion of growth. Imagine this: the universe doubled in size, not just once, but at least multiple times, over a time period so microscopic that it makes a blink seem eternal. This process, commonly referred to as cosmic inflation, proposes that the universe expanded faster than the speed of light. As for the mechanism behind this tremendous expansion, researchers are considering fields of exotic energy and even quantum fluctuations as potential drivers. So, does the Big Bang now become a mere commentary in a much more complex cosmic story? And let's take that thought further. Could this situation account for the marvelous concept of multiverses, each birthed from its own unique inflationary event? What might be the role of dark energy or even quantum mechanics in this? The doorway to answering or at least contemplating these colossal questions has been flung wide open, adding even more layers of complexity to our cosmic understanding. The telescope has also made another stunning revelation: 6 massive galaxies, aptly named universe breakers. The name isn't exaggerated. It's a dramatic yet accurate descriptor. These divine behemoths are breaking well-established assumptions about the timeline and mechanisms of cosmic formation. They're so distant that the light we're seeing from them started only a few 100 million years after the so-called Big Bang, a time when, according to established models, galaxies should be underdeveloped, not gigantic. Historically, our scientific narratives have painted a slow, gradual picture of galaxy evolution, one in which small clusters of matter gradually coalesce over billions of years to form the enormous structures we see today. The existence of these universe breakers disrupts that story. Could it be that our classical models of galaxy evolution are overly simplified? What if these behemoth galaxies were the result of conditions we have not yet factored into our models, such as varying densities of dark matter or interactions with other mysterious forms of energy and matter? Might their size and complexity suggest a previously unimaginable refinement in our understanding of cosmic formation? The arrangement of astronomical components and the complicated movement of astrophysical peculiarities are just now starting to leave an impression, seeing old cosmic systems in their childhood and re-evaluating cosmic development. Courses of events, as though universe breakers and pre-Big Bang developments weren't changing enough, we should jump into one more instigating feature of the telescope's revelations. One that is associated with having a time machine toward the finish of our adjustable focal point. When we look at these distant worlds through the James Webb Space Telescope, we're basically looking billions of years into the past. We're taking a gander at a more youthful universe, a simple baby in enormous time when things ought to have been just 2% as old as they are now. But here comes the humdinger. These aren't child cosmic systems we're seeing. They're full-grown, created, and as complex as our own personal Milky Way. This goes against past cosmological speculations, suggesting early worlds should have been tumultuous and unstructured. So, what's happening here? Are there systems at play that sped up the pace of cosmic development during the universe's early years? One charming possibility is that there could be types of grandiose manure, as yet unidentified, that sped up the development of these youthful universes. Another hypothesis to consider revolves around the distribution and dynamics of dark matter in the early universe, which might have played a crucial role in shaping systems at a faster rate than previously suspected. And here is another enticing question. If these worlds developed so rapidly, what does that infer about the life patterns of their stars and, indeed, the development of planetary systems within those systems? Could this accelerated development also lead to the quicker improvement of conditions helpful for life? It's as though we've coincidentally found a vast bend in the plot of general history, one that may very well rethink the story of our own galaxy's development too. Just to highlight how amazing this specific revelation is, let's return to the time-traveling aspect of checking out these faraway divine elements. The James Webb Space Telescope gives us the unmatched ability to be inestimable archaeologists, uncovering pieces of information about the early universe by looking into what is essentially a window to the past. What we're seeing through this fleeting focal point are not just universes, but ones that appear as evolved and intricate as the Milky Way, despite existing at a time when the universe was a mere 2% of its current age. To say that this finding overturns our past understanding would be putting it mildly, of inestimable extents. So, how did these systems grow up so quickly? What infinite recipe allowed for such a rapid progression? One possibility is the role of seed black holes. Black holes formed early in the universe's history. These could act as gravitational anchors, attracting matter more efficiently and thus accelerating the cosmic system building process. On the other hand, we could look at the role of what's known as the cosmic web, the complex network of fibers made of both ordinary and dark matter that pervades the universe. Could these structures act as fast tracks for material to come together in the early universe? And we should not disregard the idea that the components making up these universes, were their specific overflows of heavier elements, acted as a sort of catalyst for quicker development? Or perhaps these experienced universes are where we could find the first appearances of something else, a new type of matter or energy that we haven't yet encountered, which could be the key to their accelerated development. This brings us to another intriguing suggestion. What does all of this mean for our Milky Way? If universes could develop so quickly in the early universe, could that offer new insights into the Milky Way's own formative history? Might we someday find cosmic kin out there, systems that grew rapidly and could share similar qualities to our own? The discoveries from the James Webb Space Telescope are not just modifying the heavenly rulebook, they are inviting us to scrutinize the very structure of our cosmic genealogy. Just when you thought we were done overturning our understanding of the universe, the James Webb Space Telescope has one more trick up its sleeve. This time, we're diving into the hypnotizing domain of star development, with an emphasis on NGC 346, a prolific star-forming region. This part of space isn't just fascinating, it's perplexing. Loaded with dust clouds that are far from meager, NGC 346 presents us with a cosmic conundrum. You see, the standard way of thinking holds that dust clouds behave like enormous blockers to star formation, acting as hindrances or even detours on the celestial highway of stellar creation. But NGC 346 throws this idea into an enormous tail twist. Here, dust clouds aren't smothering the birth of stars, they're facilitating it. So, what kind of astronomical chemistry are we seeing here? One potential explanation might lie in the complex physics of dust clouds themselves. Perhaps these dust particles are not merely passive players but actively engage in chemical processes that allow the buildup of gas into protostars. Or maybe the dust clouds are particularly rich in specific elements or compounds that act as catalysts for star formation. We also can't exclude the possibility of magnetic field interactions, which could direct particles and gases into special arrangements conducive to the birth of stars. And speaking of stars, what kind of stars are we referring to here? Are these the typical solar-type stars we're familiar with, or are we seeing the formation of new, fascinating types of stars that behave differently and have unique life cycles? Could these be the nurseries for the largest stars in the universe? Or, on the opposite end of the spectrum, for tiny, weak stars that challenge our current models? The findings from NGC 346 force us to rethink not just our theories of star formation, but also the roles that dust and other seemingly dormant parts of space play in the workings of the universe. Are we on the verge of a revolutionary new understanding of how stars, and by extension, galaxies and even life itself, emerge? Change to a current hypothesis. It's the commitment of a seismic change in our conceptualization of the heavenly beginning. The Webb telescope pulls the enormous carpet from under us once more. This time, it's advising us to throw our old number crunchers away and prepare for some amazing number crunching. We're not talking a minor remedy or a slight change here. We're discussing a total disturbance in how we might interpret the heavenly census. As per the data, the known mass of stars in the universe at this exceptionally vast moment could be a stunning multiple times more significant than what we had previously estimated. Yes, you heard it right, multiple times. Now, let's stop and put this into context. We've all heard the idyllic thought that there are more stars overhead than grains of sand on the planet. But imagine a scenario in which the real number of stars is closer to being greater than all the grains of sand on all the beaches and deserts in the world combined. And then some. What does that mean for how we might interpret the universe? More critically, what does it mean for how we might interpret star formation itself? If these numbers prove accurate, the implications are staggering. Early star development systems must have been working at levels of efficiency that border on the unimaginable. It's like discovering that your humble engine can not only run a local drive, but is also capable of interstellar travel. So what's behind this turbocharged star creation engine? Could dark matter play a more urgent role than we thought, acting as a secret hand that catalyzes the development of stars? Or are there entirely new phenomena still unidentified that serve as the vast kindling, igniting this multiplication of heavenly substances? There could also be something even more astounding at play. Consider the possibility that these various stars aren't the result of accelerated paces of conventional star development processes we're familiar with, but are the products of entirely new, until now obscure strategies. Might there be alternative pathways to stellar existence? Different recipes for creating stars that we're not aware of yet? It opens up a chaos of possibilities, each more intriguing than the last. This discovery could mean that galaxies, even those formed in the early universe, are far more crowded places than we ever imagined. It raises questions about the kinds of conditions these stars are forming in and challenges our thoughts about how much breathing room is required for star development. It even opens the door to new kinds of heavenly formations and networks, the likes of which we've never considered. In short, this finding reconfigures not just our galactic models, but also our very sense of cosmic wonder. Are we standing near the very edge of a renaissance in our understanding of the universe? Is now the time to rework the textbooks and remap our known universe? It's an idea as awe-inspiring as the endless ocean of stars the Webb telescope is revealing before our eyes. After this hurricane tour of discoveries, one truth remains as distinct as a beacon in the dark sea of our ignorance. Our current standard model of cosmology, the revered framework that we considered our best guess at known fact, is shaking on its central support points. The building blocks of our astronomical view, once thought to be as steady as the laws of physics themselves, are showing signs of cracks. This isn't just an issue in the backup, it's more like discovering that the entire fort may be based on shifting sands. You may ask yourself, if this is true, how much of what we thought we knew is being questioned? What then, can we truly say we understand about the universe? It's a question that resonates not just in observatories and physics departments, but potentially in philosophy circles and religious establishments too. Could these discoveries eventually lead us to rethink cosmological as well as existential questions about meaning, purpose, and the nature of reality itself? And let's not forget the lingering mystery still hidden in the dark corners of the universe. For each question that the James Webb Space Telescope has helped answer, it seems to have raised several more. Are there phenomena even stranger than universe-breaking galaxies or baffling star-forming regions? What about the nature of dark energy, the mysterious force thought to drive the accelerated expansion of the universe? Could future discoveries nullify or drastically rethink this enigmatic element? Also, even the concept of time, the seemingly unchanging flow from past to future, may need re-examining. If the universe can expand drastically before what we considered its origin in the Big Bang, then what does this mean for our understanding of temporal causality? Could there be events without a cause, effects without a start? But perhaps the most tantalizing question of all is, are we ready for a new cosmological model that not only accommodates these discoveries, but perhaps predicts even more mind-bending phenomena? And if such a model exists, will it bring together disparate observations into a coherent whole, or lead us to an even more complex and fragmented understanding of reality? These are not just questions for armchair cosmologists or science fiction fans. They are challenges to humanity as a whole, urging us to rethink, reimagine, and possibly reorient our place in this unbelievably vast and ever-mysterious universe. Are we at the brink of a scientific revolution, an epochal shift, much like when Copernicus proposed a heliocentric model or when Einstein revealed the theory of relativity? Only time, and more observation, speculation, and rigorous testing will tell. As we stand on this slope of vast ignorance and knowledge, looking into the void of what we don't know, we can't help but feel a sense of wonder at the questions that await us, and the answers, elusive though they may be. Yet in the quest for understanding, we find the very essence of being human. Are you ready to step into the unknown? Because, ready or not, the universe, it seems, is far more surprising than we ever dared to imagine. In this bewildering whirlwind of discoveries, the James Webb Space Telescope has done something truly remarkable. It has humbled us. It has reminded us how little we really know, and how much more there is to uncover. What you thought was settled science is really a realm of mystery and vast possibilities. Is it unsettling? Maybe. Is it exhilarating? Absolutely. As you look into the night sky, contemplate this. What if everything you thought you knew about the universe was only the tip of an enormous iceberg? What lies beneath the surface? How much more is there to uncover? How might the next generation of telescopes and innovations further dismantle our astronomical standards? Are you ready for your reality and your universe to be flipped upside down? Remember to like and subscribe faster than a meteor. See you in our next video, who is currently appearing on your screen. See you there.